Hey, what's going on, guys? In this video we are going to solve time independent Schrödinger equation for an infinite potential well. Here we have an infinite potential well. For the potential energy function is infinity outside of this well, and inside of this well V is equal to 0. From this one we know this is a time independent Schrödinger equation, and when we solve the time independent Schrödinger equation we will get a solution like wave function solution like this. We will get psi of x is equal to a cos alpha x plus b sine alpha x. If you want to know how did we derive this one, you can watch my previous video where I had taken negative a to a and I have explained that one deeply, like I have gone from the beginning. Now when you derive the final wave function equation you will get something like this. Now from here what we have to do is we have to apply the initial conditions. Here we have the initial condition negative 3a and 3a. Instead of x we plug that one and find the solve for alpha, and finally we alpha square, because initially, like if you watch my previous video where I have taken negative a to a, I have shown what is alpha square is equal to. So here we had to solve for alpha and then square this one, and we have to equate that one with that constant, and then we will derive an equation for energy level, and that's the purpose of this one. Now let's go ahead and solve for this one. Here we have two initial conditions. The first one is psi of 3a. That's going to be equal to 0 because the particle cannot stay in outside, because the potential energy function is equal to infinity, so the particles cannot stay outside, so this is going to be equal to 0. Now if we apply this 3a to this function, we are going to have a cos 3 alpha a plus b sine 3 alpha a, that's equal to 0. And also the next initial condition is negative 3a, and if we apply this one we will get something like this, a cos 3 alpha a. I keep this one as positive because if you plug negative 3 alpha a, cos negative 3 alpha a, positive 3 alpha a is going to be the same thing. You will get the same result, so we don't have to change anything. But for sine it's different. If you put negative 3 alpha a, that's equivalent to negative b sine 3 alpha a. So instead of putting the negative sign here, I can move this negative sign right here and keep this one as positive. So this is going to be just b sine 3 alpha a, that's equal to 0. Now we can add these two together and subtract these two, and when you add these two together this sine function will become 0 because we are adding plus and minus. So this will become 0. You will get the cos function, you will get something like this, 2a cos 3 alpha a, that's equal to 0. And from this one you can solve for alpha easily, because this 2a divided this 0, that's going to become still going to be 0, because if you divide 0 by anything that's going to give us 0. And cos 3 alpha a, we can solve this one because we have to see what value give us 0 for cos value, right? Then you plug the value and that's gonna give us the solution for alpha. And if you solve for alpha you will get something like this, n times phi divided by 6a. Here n has to be odd number. Like for example, let's try some numbers. Let's say we have for example 3 phi divided by 6a. 3 phi divided by 6a is what? Phi divided by 2, right? Phi divided cos phi divided by 2, that's equal to 0. So you can plug any odd numbers. For example, if you plug 1, that's going to be true. If you plug 3 times 3, that's going to be 9 divided by 6. So 3 phi over 2 still going to be 0. So that's how we derived this equation. Now n has to be odd number. So this is for the cos function. Now when you subtract, you will get the equation for sine function, where you will get alpha is equal to n phi over 6a, but here the n has to be even number in order to get 0. Now these are the two things we will get, and finally we will use this alpha to create an equation for energy. And when you find the energy you will get an equation like this, En is equal to n square phi square h bar square divided by 72 ma square, and that's going to be the final derivation of energy level equation for this particular infinite potential well. I hope this helps. Thanks for watching.